Hi everyone, I'm Cheryl. In this problem, we're asked to use a triple integral to evaluate the volume of the solid that is pictured. Well, I know that to find the volume, again, I'm going to need a triple integral. What I need to do is to decide which variable I will be integrating with respect to first. And I'm going to choose a dz to begin with. And then I'll need to choose my other variables of integration. But before I do that, let's go over to our picture and look at a representative element to help me set up this problem. So again, as always, I can look at this in a variety of different directions. I'm going to choose a representative element that's going to go across this way so that I've set it up horizontally. And I'm going to take little pieces. And if you can imagine one of these little squares, if I project it up, if I pull it up, it's going to create a little prism. Okay. That's going to be the height. That's my dz. That's why I've decided to integrate with respect to z first of all. The way I have this set up though, it looks like I am integrating with respect to x, so I'm changing the x, and then once I get this rectangle, I'll move it from here back to here, so that will be a change in y. So dz and then dx dy is the way I have it pictured. Now I need those limits of integration next. How am I changing z? Well, z is going from 0 up to this plane. And I know that this plane can be represented by z equals x. So I'll be integrating from 0 to x. Okay, how about the x's? As I change those x's, I'll be going from 0 out to this value. Well, this value is going to be 4 minus y squared. So I'll be integrating from 0 to 4 minus y squared. And then finally, when I move all those rectangles across, I'll be going from this point to this point. This is actually 2 to negative 2. So I'll be integrating from negative 2 to positive 2. All right, now I have my triple integral set up, so I can begin by working on the inside piece. So I have the integral from minus 2 to 2, the integral from 0 to 4 minus y squared, and the integral dz is just going to be z. And I'm evaluating that from 0 to x. And then I have my dx dy. Plugging in the upper limit and subtracting what happens when I plug in the lower limit, I'm going to have x minus 0, which is just x, dx dy. Now I can move and work on the next integral. So I'll still have the integral from negative 2 to 2, and I want to integrate x dx, which will be x squared divided by 2. So that's x squared divided by 2, and I'll evaluate that from 0 to 4 minus y squared dy. Plugging in my upper and lower limits and subtracting, I'll have 4 minus y squared quantity squared all over 2 minus 0 dy. Okay. Now I'm ready for that last integral. I'm going to move it up here. And I think what I'll do is before I work on it, I am going to multiply this out. So I'm going to have 16 minus 8y squared plus y to the 4th all over 2 dy. Just using FOIL. Doing a little more simplifying with the integrand, I'll now have 8 minus 4y squared plus 1/2 y to the 4th dy. All right, my integrand's simplified now, so I can go ahead and integrate. So I'm going to have 8y minus 4/3 y cubed plus, this will be 1/10 1/10 y to the 5th, evaluated from -2 to +2. Plugging in my upper limit, I'll have 16 minus 4/3 times 8 plus 1/10 times 32. Then I need to subtract what happens when I plug in the -2. If I plug in a -2, I'll have a minus 16 minus 4/3 times a -8 plus 1/10 times a -32. So let's see. I have 16 minus 32 over 3 plus 32 over 10 plus 16 minus, because we'll have a positive 32 over 3, but then that's negated. So that'll be a negative 32 over 3. And this will be a negative 32 over 10, which becomes a positive 32 over 10. Now I'll need to get a common denominator. The common denominator happens to be 15, and with a little arithmetic, you can find out that the result is 256 over 15. I hope that was helpful. Thanks.